everything down to fireproofing the building steel, caulking of any kind, including on the building cladding, wood products such as casework, ductwork sealant, and pipe adhesives all care about temperature and humidity. If the humidity inside the building is high, it can actually rain inside the building. Welcome to the Management Under Construction podcast. I'm your host, Dee Davis, and get ready to geek out on temperature and humidity and why this is important during construction. First, let's familiarize you with the basics of humidity. I think we all know what temperature is. It's either too hot, too cold, or we're comfortable, right? But humidity is something that I recently realized that not everyone really understands in the way that people with HVAC backgrounds do. I actually encountered someone the other day that had zero understanding of what humidity even meant. And it occurred to me that this could be the root of the problem that we often encounter in construction. Us mechanical people, we think everybody knows what we know. We intuitively understand because of our education why it's important, but we don't realize that not everybody gets it. So let's talk about it a little bit today. The measurement of humidity, often called relative humidity or written as RH, is the measurement of the amount of moisture in the air. How much moisture is in the air, or could potentially be in the air, varies based on a variety of factors, including temperature. Most of the United States, and indeed most of the planet, is in a constant state of humidity of about 50 to 60% or more. There's a few exceptions to this, and my home state of Colorado is one of them, where the normal humidity range there is more like 20 to 40%, resulting in a lot of static electricity. The range of human comfort, however, is 40 to 50% is kind of the sweet spot for human beings. So depending on where you live, you might say it's too dry here, or more likely it's too hot and too humid here. We feel the temperature much, much differently when there's more humidity in the air than when there's less. I often tell people that, even when we have hot temperatures in Colorado, it's not the same. Even when we have cold temperatures, it's not the same as you experience it in other parts of the country because the humidity is so low that 30 is fine for short sleeves and 90 isn't too hot to go outside and do something because the humidity is so low that you don't feel it in the same way that you feel those temperatures at 60, 70, 80% humidity. Most climates are either too dry or too humid to be very comfortable for most people. The higher the temperature, measured in centigrade or Fahrenheit, doesn't matter, the more moisture the air can potentially hold. And the lower the temperature, the less moisture it can hold, which is why your skin tends to get so dry in the wintertime, and you get that pesky thing that I hate the most about dry climates and wintertime, which is static electricity. Zap every time you go to touch something. It's my only complaint about Colorado. In mechanical engineering, we have this really complicated chart called a psychrometric chart that looks more like an eye chart that was made by a drunk cross-eyed guy. It looks a little more complicated than it really is, but what it tells you is at any given temperature, how much moisture, measured in grains per pound of dry air or humidity, can be held in the air. When the temperature and the moisture level collide, we get things like fog, dew, and even rain. In winter, we can get freezing fog, which produces absolutely the most beautiful winter landscapes you've ever seen in your life. It's my favorite. In short, warmer air holds more moisture, which is why it can feel heavy, muggy, or humid. And in winter, it's more dry because it can't hold as much moisture. And so we get those cracked lips, dried throats, need to use eye drops, things like that. Now, why does all this matter to us construction people? Well, it matters because There's so many components in construction that are sensitive to temperature and humidity swings. Everything from paint, sealants, and flooring have specific temperature and humidity ranges recommended by the manufacturer for application or installation. If we apply a coating, such as paint, towards the top of an allowable humidity level, it could take 3 to 4 times longer to fully cure than if we apply it towards the bottom of the temperature and humidity range. If you apply a coating, a sealant, an adhesive, or flooring outside the recommendation, warranties are very likely to be voided and material failures can occur. You, the installing contractor, would then be responsible for the failure, the demo, and the reapplication of the work at your own expense. We don't want to go there. When I was young in my career, it wasn't common for buildings to have any kind of really space conditioning during construction as long as it was relatively mild climate. The only contractor that would fuss about it back in those days was usually the flooring contractor or maybe the cabinet guy. Then LEED and similar green building initiatives started to be implemented, and the industry pushed hard for lower volatile organic compounds, or VOCs, which we've talked about in previous casts, lower VOCs in the finishes. This was a landmark time in the industry, and our first attempts at low VOC paints and adhesives were a massive failure. We had flooring that wouldn't stick, caulking that would fail, paint that would come right off the wall. It was a mess. Installation temperatures and humidity started becoming more important inside buildings under construction, even in mild climates. Our next challenge was to provide space conditioning while buildings were still under construction. Temporary equipment is expensive, and delivering tempered air in a way that manages temperature and RH consistently in the building when ductwork, piping, and electrical are still being installed is a challenge indeed. This has been somewhat addressed by accelerating the installation of permanent equipment, piping and ductwork, and usually temporary power. This still holds several challenges. The building has to be in a certain state to achieve this, and it puts the owner's equipment into service long before the warranty and maintenance should start. We're going to have a whole separate podcast for putting equipment into service before it should be. However we decide to achieve temp conditioning in the building, it's really important to do it earlier in the project than you might think. Everything down to fireproofing the building steel, caulking of any kind, including on the building cladding, wood products such as casework, wooden doors, cabinets, and flooring, epoxies, any kind of flooring really, coatings for steel, pipe, and walls, ductwork sealant, and pipe adhesives for mechanical joints all care about temperature and humidity. In addition to coatings, adhesives, and finishes possibly not working like they're supposed to, there are other risks. If the humidity inside the building is high, it can actually rain inside the building. I've had this happen a couple of times. It's crazy. You come in one morning and it's raining inside your building. I mean raining, like dripping from the ceiling and water cascading down the walls. It's not because of a roof failure. It's because the humidity level and the temperature have collided in your space to create its own little rainforest. Besides the fact that it's not supposed to rain inside buildings, it can result in failed finishes and that 4-letter word nobody wants to hear, mold. I think we're going to do a whole episode on how mold can start early in construction, but suffice it to say that when drywall gets wet, or wood, even mold-resistant drywall, mold spores can begin to form deep in the building materials that eventually turn into mycotoxins that are extremely harmful to human health, causing everything from cancer to Alzheimer's and Parkinson's disease. Raining inside your building, building finishes, and building materials getting wet is a very, very bad thing for construction. We want to manage that temperature and that humidity as early as possible. If you're building anything like a clean room, managing that temperature and humidity is even more important because mold spores cannot get an opportunity to start to grow during construction. And what most people don't realize is just because you can't see it doesn't mean it's not there. We've got to manage that temperature and that humidity inside that building during construction one way or another. Even if you have to bring in porta-cools to do it, that's a very common way of managing that. Thanks for joining us. Keep those buildings dry and comfortable. We'll see you next time. This episode was sponsored by Davis Consulting Management Group, serving the life science industry with owner's representation, construction management, and subject matter experts across the United States. Reach out to DCMG at info@dcmg.us or visit their website at www.dcmg.us. Thanks for joining us. Do you want to be a guest or do you have an idea for a topic? Email me at heydee@managementunderconstruction. That's HEYDEE@managementunderconstruction.com. Are you looking for custom ongoing education for the construction industry that's customizable to meet you where you are on your journey? Contact Yellowstone Professional Education at info@yspe.co.